This is class lesson 3.7, part 1, inverse functions. We're going to begin with number 1, and we're asked to decide whether each function is one-to-one or not. Now notice in this first function, this is a line with a slope of -3 that passes through positive 7. Oops, I didn't do that very good. So obviously, this is one-to-one. It passes the horizontal line test. But keep in mind that every linear function is one-to-one. Now, I say every, but don't forget we have that constant function, that f of x equals c. That is not one-to-one. Okay. But every other linear function is one-to-one. Let's take a look at b. Now, graphically, if you take a look at this, this is actually, there's -7, there's +7. This graph is actually the upper half of a circle. You can put it in your calculator and check it out. And this fails the horizontal line test. Therefore, it's not one-to-one. Something else I want you to think about is for a function to be one-to-one, you cannot have any repeated x or repeated y values. So you could actually let x equal, let's say, -5 and +5. And if you plug that in, you'd have the square root of 49 minus 5 squared, and you'd get the square root of 24. But look at this. The square root of 49 minus -5 squared is also the square root of 24. So although our x coordinates are different, we have repeated y values. So not one-to-one. Okay, number 2, definitely graphical method. If someone gives you a graph, definitely use it. Use the horizontal line test. Therefore, it is one-to-one. Fails horizontal line test, therefore not one-to-one. Now, let's look at number 3. We have two functions, f and g, and they tell us that g is the inverse function of f. And we want to see if these functions are inverses of each other. So what we need to check is f composed with g of x, and see if it's equal to x, and g composed with f of x equal to x. We have to satisfy both of these. Okay? So let's give it a try. F composed with g of x is f of g of x, f of 1/2 x minus 5. Now, everywhere there is an x in f of x, we're going to put 1/2 x minus 5. So we have 2 times 1/2 x minus 5 plus 5. And we get 1x minus 10 plus 5, and we'll get an x minus 5. That is not equal to x. Therefore, f and g are not inverses of each other. There's no need to check g composed with f of x, since both of those have to be true. Moving on to number 4, find the inverse of each function that is one-to-one. Now, if you look here, we have all of our x values are different, and all of our y values are different. We have no repeated. So therefore, f is one-to-one, and f inverse exists. So let's go ahead and find f inverse. All we're going to do is interchange the x and the y values. Some of these are repeated, so it's quite simple. And there we go. Let's look at 4b. What do you notice? As you can see, I see a repeated y value. I also see another one. So this function, g, is not 1-to-1. Therefore, g inverse does not exist. Okay, let's talk about number 5. Let's go to 5a. Find a domain on which each function is 1-to-1. So we're just going to take a piece of these graphs. Let's look at this first one. Now, this is the squaring function that is, actually, let me redraw that. Shifted to the left, 7. So 1, 2, 3, 4, 5, 6, 7. And that's it, just shifted to the left 7. So it looks something like this. And that is definitely not 1-to-1. So we need to go ahead and restrict the domain. So we're not going to use that part, only the highlighted yellow part. And our restricted domain might be -7 to infinity. And that way now we have a 1-to-1 function. Okay, let's look at the last problem. This is the absolute value function translated down 5 units, and it looks like this. Now, as you can see, this fails the horizontal line test. So we'd like to restrict this domain so that we could write an inverse if we wanted. So let's just take this piece of the graph here and not use that part. So our restricted domain, 0 to infinity. And that concludes the